Hello and welcome to Domain and Range. The domain then is the set of all possible values for the independent variable in a relation. We shorthand that to say all of the x values. The range is the set of all possible values for the dependent variable in a relation, and we shorthand that to say all of the y values. With those definitions in mind, if the domain is all of our x values, then the domain for this one is going to be 1, 3, 5, 7, and 10. And you'll note when you look at the points listed below that all of the domain is all of the x values. The range then is going to be all of the y values, and I've rearranged these into numerical order so they don't actually follow the exact same as the list below. And we have 1, 3, 5, 7, 9. In this example, we have a linear function. When we're looking for the domain and range, we first try to determine where the endpoints are. But with a linear function, we know that this can go on infinitely in both directions. With that in mind, then, we determine the domain to be this. Curly Q brackets are traditionally used, x and then a vertical line meaning such that, and start with our smallest endpoint, so negative infinity is less than or equal to x, which is less than or equal to our positive infinity, and we always have to identify our numbering system. In this case, that would be the real numbers. Now we can shorthand that as x belongs to the reals. The range follows the same pattern. Use the y now, but negative infinity less than or equal to y less than or equal to positive infinity, y belongs to the reals. Or shorthanding it, y belongs to the reals. In the example here, we have a quadratic. As with the linear, we are looking to see if we can figure out endpoints, and with the domain, we can assume that these two lines are going to go off in both directions infinitely. So our domain remains the same. We have x such that negative infinity is less than or equal to x, less than or equal to positive infinity, x belongs to the reals. And we recognize that we can shorthand that as simply x belongs to the reals. Where we have a difference in this case is now we have a bottom. There is a least value for our range. With that in mind then, when we go to define our range, we look at y such that, and because this is opening upward from the vertex, we can simply look at it as y is greater than or equal to 2, y belonging to the reals, and close bracket. In this last example, we have another quadratic, but this time we have a maximum value. So our domain is still going to remain the same, and I'm just going to use the shortened version, x belongs to the reals, and move quickly into the range then. Since our range has a maximum here of 6, then when we go to record the range, it is going to be y such that y is less than or equal to 6 belonging to the reals. I hope this quick tutorial helps.